Hi, everyone. My name is Amy Ghate. I'm a solutions architect at Elastic, and today I'm going to be talking to you about asset tracking and location intelligence with the Elastic Stack. So the agenda for today is to go over what asset tracking exactly is, how you get data into Elastic, geodata, and then how do you get that data onto a map? And then finally, how do you make that data operational? How do you set up alerts and geofencing so that you can actually take action on the data that you're ingesting into Elastic? So what is asset tracking and why is it important? When I say asset tracking, what I'm talking about is tracking actual moving physical assets that are broadcasting their location by using things like GPS or RFID or any other technology. And this is specifically important, especially in logistics businesses that need to track assets in near real time. A lot of that involves improving operational efficiency to understand where something like a delivery van or something like a DoorDash driver is, and also for customer service. So if I, as a customer, am tracking something that's being delivered to me, I need to know where that asset is. And finally, safety on the job. So oftentimes in logistics scenarios, there are zones or areas or obstructions that you may not want your asset to come into, or imagine a train going through a tunnel. You want to know where it is. The act of geofencing and drawing a virtual perimeter for a real world geographic area allows you to exercise the safety on the job and know when your assets are entering an area that maybe is dangerous, maybe they're not supposed to be in, or might cause a delay in delivery. So there's a lot of data that is generated by connected devices. So, 20 billion plus connected IoT devices as of 2020, 6 billion GPS equipped smartphones. So there's a lot of data, large volumes of data being generated, and that needs to go somewhere. And the Elastic Stack is a perfect place for that data to be ingested and operationalized. So the first step into making data operational in the Elastic Stack is ingesting that data into the stack. So Elasticsearch has supported geospatial data for a long time, and specifically it supports these specific data types. So a geopoint is a single pair of latitude and longitude coordinates. A geoshape is a geometry that consists of lat-long coordinates. And finally, if you're doing something like indoor mapping, the shape data type can support any type of Cartesian geometry type. So all of these, all of your data that comes in can be mapped to one of these three data types and be ingested into the Elastic Stack. Now, what are the best ways to get data into Elastic? Well, if you're familiar with Elastic Stack at all, you know that beats, which are lightweight data shippers, are the best way to get data into Elastic. Very specifically, if you have geodata that's sitting in CSV files in CSV format, using something like a file beat is great to put in there. In this slide, we have all of the beats, but specifically for geodata that might be published in CSVs, file beat would be the way to go. But oftentimes you need something, an ETL tool, something that enriches that data as it comes in, and that is Logstash. So in this flow, you have data either from beats or data coming directly from IoT or sensors or an API endpoint, which is what I'm going to show later on in my demo, coming into the stack, Logstash transforming it in some way. One way that it can specifically enrich in a geo way is to enrich it via the GeoIP module. So data comes in, is enriched, and then goes into the Elastic Stack, or is transformed and goes into the Elastic Stack. And then finally, for those people that are familiar with the GDAL toolset, there is the ability to ingest with Ogre to Ogre and read and write into the Elastic Stack. There's 2 blog posts that are listed here that show exactly how to do that and that talk about the Elasticsearch plugin and parser. And later on in the resource slide and the PDFs that get sent out after this session will go into detail about how exactly you can do that. Another great way to ingest data in a simpler way is actually with the CSV file upload. So if you have a CSV file that has the data in there, you can upload it and import it, as you can see in this clip right here, create an index of that data as it's being ingested. It's going to combine the fields and actually create that GeoPoint data type in that GeoPoint field as part of the data import process. And you should be ready to visualize your data after this import. And then finally, another way to upload GeoJSON, to upload shape data or geodata is through the GeoJSON upload. This is a feature that's part of the map application. And you can see here, in this particular clip, shapes are being uploaded, specifically New York City boroughs are being uploaded as GeoJSON, as shape data, and is displayed on the map. So now that I've gone over how to get data into the stack, how do we get that data onto a map? Elastic Maps is an application within Kibana that lets you build maps with multiple layers and multiple indices. It has a lot of great data-driven styling, so you can style your map any way that you want. You can animate temporal data if your geodata has a temporal quality to it and you want to animate that on a map. The map application gives you the ability to do that. And aggregations. Elastic is great at search and aggregating really large volumes of data, and that's no different in the maps application. So the heat map, clustering, grids, being able to do things like centroids of a group of geodata are all available through the map app. And then finally, queries, being able to search through that data, do things like bounding box queries, point and polygon queries, and distance radius queries are all available functionality through the map app. And then finally, the ability to embed those maps that you've created into dashboards, into canvases. So these are all part of the Elastic Maps application in Kibana. Today, I'm going to go through a demo of how to get data from an API endpoint onto a map. The data that is being presented on this map, this is the end product that we want to see, obviously with the points moving around, but this data is coming from TriMet, which is Portland's bus system, and it is sending data from its buses, coordinate data of the location of these buses through an API endpoint, through a REST endpoint that I have access to and that I'm ingesting into the Elastic Stack and then displaying on this map. And so the first thing that I had to do was obviously to sign up for this data. And then I needed to get that data via Logstash into Elastic. So this is the Logstash pipeline that I wrote. And you can see here that it is pulling this endpoint, ingesting that data, doing some transformations on it, adding fields, modifying the fields that are coming from that data into a mapping for Elastic, and then finally sending it to my Elasticsearch cluster that is sitting up in the cloud. All right, so this is the finished map, and this is what what this demo is trying to achieve. And the very first thing you saw, the Logstash pipeline, is to create the index and then create a mapping. So here I've created the index and I have created this mapping, and I have the Logstash pipeline running, and it is sending data. As you can see here, it's sending data to this map. So now that I have data coming in, I want to create this map. And then again, this is what I want the map to look like. So I'm going to go in, and this is the Maps app, and I'm in the part of the map where we can create and modify the layers. So I have the roadmap layer, and what I want to do is edit this layer and make it a little bit darker so that the data that I put on it can be seen. So I'm going to come and save and close it. And then I'm going to add another layer. And what I want to see are the tracks. And so I'm going to create track data. So this creates lines from points. And the points that are coming in are those coordinate locations of all the buses that are moving around in Portland. So I'm going to come in I'm going to create the tracks, and I'm going to select the index that I created in the earlier step, and I'm selecting an entity. And the entity is, how do I uniquely identify the data that's coming in? How do I uniquely identify each track? And in this case, vehicle IDs are unique. And so I'm going to come in and I'm going to add the layer. And I'm going to name the layer. So I'll just name it buses. And I'm going to give it a pink color so that it shows up nicely. And the other thing I'm going to do is just reduce the opacity so that if this was an operational dashboard and the road layer underneath needed to be seen, that's available as well. So I'm going to come in and I'm going to save and close it. And I'm going to go to this data. So yep, so we can see that the data that's coming in is the tracks from that data are being generated. And so the next thing that I want to do is I want to know where the bus is at a current point in time. And for that layer, I'm going to choose the top hits per entity. And what that does is it displays the most recent data point for that entity that is available. And again, I'm going to select my bus data that's coming in, and the entity again is this vehicle ID that uniquely identifies. And you can see, this is the latest document for that entity that's available. Great. So the time obviously is the field that we're looking at. And so I'm going to add that layer. And again, I want to style this. So I will come in, and in this case, I want an icon. So I want it to be an arrow. I'm going to choose the arrow icon. And I talked previously about data-driven styling and how Elastic Maps allows you to do that. And so I'm going to use that to fill the arrow color. I'm going to do it by value. And what I want to know is, are buses in traffic or not? And I want that informed by this data-driven styling. I'm going to come in, create a custom color palette, and I'm going to say the default is black. And then if it is not in congestion, so false, I want it to be green. And then if it is in congestion, I want it to be colored red. So you should see a couple of arrows here change red. And then finally, I'm gonna make the border width 0. And the other thing I want to do is I want these symbols, I want them facing the direction that the buses are going in, right? The symbol orientation, I want it also data-driven by a value, and that value is by the bearing of the bus, which is data that is coming in from the feed from the Portland bus data set that's coming in. So great. We see here that we have now been able to put the track data on the map, put the icon showing directionality of the buses on the map, and we have it updating every 2 seconds so that the data as it comes in animates this map. All right, so we will come and save and close this. All right, so the next thing that we want to do is, now that we have the track data on the map, we want to set up fences. So I talked previously about what geofencing is. This is creating perimeters on the maps that allow you to alert on when a asset is entering that geofence and also exiting that geofence. So we want to make this data on this map operational. And you can imagine these geofences for a bus data set would be great for telling a rider when a bus is approaching them, when a bus has left a station, where, if it's crossing into traffic, anything like that. So just a quick overview of alerting in the Elastic Stack. So Kibana alerting is integrated with Kibana at the solution level. So for all of the major solutions that Elastic offers, observability, security, that alerting is integrated into Kibana, as well as maps and machine learning. If you all are familiar with alerting and have used Watcher, Kibana alerting is a new way to do that. Watcher is low-level alerting, and Kibana alerting gives it a UI and allows you to do many of the things that were done by Watcher before, which still exists as part of the stack, but allows you to do it through a UI and configure it. The alerts are integrated with action with actionable endpoints, including email, Slack, Teams. You can output it to an index, to a webhook, and lots of other options to servicing platforms like Jira, ServiceNow, GitHub. All of those are available. So when an alert fires, you can send that data off to someplace and take action on it. And again, before we had the map with the data moving around, and now we're going to add some geofences to it and set up alerting. Okay, so we are going to add a layer onto this map, and there is a way to add data to this data set really quickly. So we're going to just create an index, and I'll name the index, I'll name it construction zones demo. All right, great. So we're going to create this index, and I am going to add shapes onto it. So I'll add a shape here. Add a shape right here. And let me add just one more shape right here. All right, great. So now, and I'll also come in and make this, let's style it a nice yellow so it looks like construction zones. All right, great. So we've created this construction zone data set, this shape data set. It's on the map. We're going to save and close it. And the next thing that we want to do is set up alerting based on this. So alerting in the Elastic Stack is under stack management. So I'm in the stack management pane right now, and it is right here under rules and connectors. So I'm going to click on this, and I've already created a rule, but I'm going to create another one just to show you all how to go through this process. So we come in here and we click on create rule. In this case, I'm going to call it buses alert. And I'm going to have it check the status every 30 seconds. And I only want to be notified on status change. And you can see here all the different types of alerts that are available. The specific one that we're going to be configuring is called tracking containment. So alert me when an entity is contained within a geo boundary. So when I come and click on this, I have to choose the entity. And in this case, or I have to identify the entity. In this case, it is located in this data set or in this index. And again, we're going to be looking at vehicle IDs because those are unique. Those are what constitute the entity in that index. And here I'm going to select the boundary. And I created this construction zone demo data set. And in this case, I am going to select the server log output as a connector type. I'm selecting the connector that I already created, and this is a server log connector already created before I set up this demo. And the information that we want in the message, I'm going to pull from the documentation. So one great thing, everything that I showed today in this demo is actually available in our maps documentation, and you can set this up yourself. So after watching this, if you want to try this out, please go to this documentation, which is going to be linked in the resources section, and try it out. I'm going to go all the way to the bottom, and I'm going to pull the message data, and we can see here this is all data that is pulled from the documents and from the bus data. So I'm just going to come and copy this. I'm going to select it and paste it into here. So this should give us the vehicle ID. It should give us the date, time. It should give us the location and also the boundary that it crossed. And I didn't name them, but if you have actual shapes that are coming in, those will have names and metadata of their own. And so you can get that information in the alert. I'm running this alert when tracking containment is met. You can also say when no longer contained. So when an asset leaves a boundary and generates an alert, you can also alert on that. So I'm going to come in here And I'm going to save this. And you can see here that it should be created momentarily, and it's going to run every 30 seconds. And the one that I created earlier is active and running. And if I come in and click in here, you can see times that it was activated and just how long it's been running and tracking that information. All right, so we went through how to get data on a map and how to create geofences and alert on them. All of the resources that I talked about in this demo are available online, and they'll be sent to you as part of a PDF resource. And just a quick recap of what we did today. So we talked about what asset tracking is, why it's important, how to get geodata into the Elastic Stack, how to use the Maps application to visualize that data, and do some cool data-driven styling with it, do some animation with it, and then finally, how to use that data to set up alerts and set up geofences in the Elastic Stack. I hope that you found this useful, and thank you so much for listening.